the questions, anyone? Okay. So
awesome.
Thank you,
Okay.
everyone. Appreciate it. Seriously, great introduction to optimistic rollup and other stuff. So the next presenter we have is Nick from Fuel Labs. He's a developer there. Fuel Labs have been working on optimistic rollup payment solutions on Ethereum. And Nick, if I'm explaining it incorrectly, please correct me. But please take over and then explain yourself, explain Fuel Labs and how you're using optimistic rollup. And of course, we'll have a second round of questions right after.
Awesome. Great. Okay, I'll share my screen. We'll go from there. Now, I can never figure out, do I share screen and then present? I mean, I'll just have to, there and then present. Okay. Can everyone see that?
Got it.
We good?
Yep.
Yep.
Great. Awesome. So welcome everyone to another day of crypto in pandemic land, in the world of pandemic. So yeah, thanks for the intro. Yeah, I'm Nick, and I'm the founder and lead dev for Fuel Labs. So I'll just go through our solution today. I thought that was a great intro on a lot of the optimistic rollup and ZK rollup stuff. I think channels could have also been mentioned, I guess, but you know, that's we can cover that later. Channels have had their time and haven't come to fruition yet, so we'll skip channels. I understand.
They got enough time to prove themselves, but didn't work out, unfortunately.
Yeah. We'll see as a cross-chain thing as channels develop. Yeah. But and I also think too, XDAI should get a mention as a layer 1 / a bridge. Also very useful, different cost model, different security model. But yes, a layer 1 bridge, so different. Cool, awesome. So let's start with just a Fuel background. So Fuel is a permissionless, trustless layer 2 protocol for Ethereum. So we do low cost, high throughput value transfer and exchange. And we're basically building the most optimized or highly optimized optimistic rollup you can produce. And our main focus is on parallelism. So everything takes priority, but parallelism takes the most priority in terms of what our users need and what we want to deliver for the platform. So and we have a big focus on that. And as well, it's in our roadmap to deliver, which you'll see in the future, because I know smart contracts were brought up, UTXO-based Ethereum style smart contracts. So we'll go over that at the end. But right now, the main focus is just get to the highest optimized system we can possibly think of. Cool. So what can we do with Fuel? So, you know, we've gone over optimistic rollups. We kind of know how they work. So now I'll go over what Fuel and the current version of Fuel is focusing on right now. So, so Fuel supports all ETH and ERC20 tokens. We also support NFTs through wrapping. In our next version, we'll support, you know, even better NFTs without any wrapping. I can go into that later. A main feature between us and just the transfer rollups, whether that's ZK or optimistic, is that we support multi-user transactions or swaps or partially signed transactions, which means that users can do all sorts of different magnitudes of on-chain trustless exchange. So this is atomic swaps between different token assets, and you can build, you know, any order of magnitude of non-custodial order book systems with this, or have any other model you want. Order book is only one. You can do any sort of settlement you want, but it's more, you can think of all the new arbitraging opportunities that are probably going to arise from DeFi. You probably don't want to settle all of those on chain. So there's lots of opportunities to, you know, both get the benefits of scale and trustlessness, but basically, yeah, be able to match an order somehow off chain. So the next thing we support as well is an op return style output. So this is good for arbitrary data and the officiation of arbitrary data. So you can imagine situations where you want a lot of censorship resistant publishing. So this could go for like a Wikipedia, a Twitter, or discussion systems. You know, what we wanted to do was effectively at least be, well, because we're a UTXO style optimistic rollup, which I can explain later, you know, a big focus was to make sure that that we had ways to at least publish arbitrary data As well, you can use the arbitrary data publishing system to build these sub rollups off of ours, but that's sort of a secondary thing. And I can get into that later as well. The next thing we support is native hash time lock contracts. So a really important thing that I think is going to surface as we get into layer 2s more and more, and as people start using them and adopting them, is how you move between layer 1 and layer 2, and how you move between different layer 2s. So this is a really critical thing, and currently we have a fantastic solution thanks to the Bitcoiners who have actually thought of a lot of all of this already. They just never implemented it. So even optimistic rollups, to an extent, had been talked about at some length by the Bitcoin community, but they never implemented it, which is a common pattern. So we like to think of Fuel as the chain that actually did all the things Bitcoin never got to. So a lot of parallelistic opportunities, and you know, a lot of different contract realizations. So hash time lock contracts are really cool. They allow you to do cross-chain atomic swaps. So that's with other chains. That could be between things like Bitcoin and Ethereum. That could be between you know, different layer 2s. So between, say, Fuel and Arbitrum, or Fuel and Optimism, for example. And it can also be between you know, Fuel and layer 1, or you know, different layer 1s. So hash time lock contracts are really simple contracts. You're just locking it up for a certain period of time, and then you're revealing the inner pre-image, which is going to release the funds on both sides. So long as parameters are set, these are both really safe. There's very few issues, and they allow you to do you know, fantastic value and liquidity swapping and transferring, you know, without being stuck on any one system. So we're working with a few teams actually to bring this to fruition on a bunch of different rollups and a bunch of different layer 1s. So this should allow value to just flow freely between all the different solutions, so you're not stuck, which is you know, going to be a big issue. You don't want to be stuck in a rollup, especially a rollup that will eventually be updated. So you know, you want ways to do that. And that brings me to my next point, which is HTLCs are also great for migration. So migrating between rollup versions, so this is another issue. So long as you have the same token on both versions, and you have the same amount of value, you can just do these hash time lock contracts and swap between them. There are other ways of doing migrations that we're implementing that are even better than this, but this is our current solution for migrating from Fuel v1, for example, to Fuel v1.5. And this is without ever touching Ethereum layer 1. So pretty critical. You don't want to have to go back to layer 1 again to get to the next layer 2. So yeah, HTLCs are pretty important. Cool. So the next thing that Fuel is pretty good at is an interesting dispersal pattern that we picked up by using the UTXO model, which is pre-signed transaction trees. So this allows for a sort of Merkleized distribution, or you know, like a dispersing tree, which allows you to do these sort of massive, potentially millions of token airdrops and pickups. So Fuel also entered the Reddit challenge, and this was actually something they wanted in the submission, which was a way to disperse massive amounts of tokens to a lot of users, but they wanted it to be a pickup style model. So we actually allow this through our pre-signed transaction chains. And so this way you get this like fantastic system where, you know, you can mint all of the transactions and sign them. You can store them in a database, but only when the user actually wants to go pick them up does it actually fire the chain of transactions in order to be able to disperse that. So you get a nice, secure, simple pickup mass token airdrop model, which is a really nice pattern from the UTXO model that we have natively. Again, with the pre-signed transaction chains, we also noticed a way to do things like digital subscriptions. So being able to sign a massive chain of transactions ahead of time, and then being able to disperse them through any means you want, you know, over time. So this is another use case that we covered. And once again, we're really trying to push the limits of, in the UTXO setting, what are all the possibilities? Like, let's explore absolutely everything we can do with this. And of course, our main focus is still transfers and swaps. But it's actually kind of amazing with just this data structure alone, we were able to kind of pick up on all these different use cases. And then the next thing is mixers. So because we support 8 input in, 8 output transactions, you can do a decently secure transaction mixer, for, obscure transaction graphs. And so this is just enough to do enough mixing off chain if done properly to give you a good level of privacy. I mean, we're not talking about hiding from the NSA level privacy here, but we are talking about hiding from your neighbor and things like that, the less sophisticated. So, really useful ways to do simple mixing that's also really efficient. So that's just another example. Another thing with the hash time lock mechanism is you can do token weighted voting. So because hash time locks have a locking feature to them, you can basically do off-chain and on-chain verifiable token voting. So off-chain, you would do just a basic verification of signatures based upon a certain token. On-chain, you can actually reference the proofs in Ethereum smart contracts. So you could actually bring it to chain if you ever wanted to. And so this is also a nice feature of just having that accessibility. Of course, if you were using something like a ZK proof, randomly verifying a bit and piece of a specific transaction like this would be extremely difficult. So the optimistic rollup, the data is nice and simplistic. Bringing that into other smart contracts is really straightforward, and bringing the proofing into other smart contracts is straightforward. So this brings me to just talking about layer 1 and sort of what is layer 1 now. So we know optimistic rollups are a thing. We know that rollups are likely to be where we do a lot of our work for our users and we get a lot of the business logic done. But what does this mean for layer 1? What does layer 1 become? So the way we see it is layer 1 still incredibly important. I mean, not only as the way that we operate and expand scale and rollups, but as a base settlement layer for token issuance, for your base protocol, and for settlement. So you always want your system to be settled eventually somewhere on layer 1, whether that be through a rollup or not. But I mean, you could imagine a scenario if you're issuing a token on a layer 2, and then the layer 2 upgrades, and then now your base protocol token is in a old rollup that is needed to be upgrading. So minting and issuing your base asset on layer 1 is like the big banking layer. You can consider it that way. And layer 2 should be used, I think, to expand, add scale, and reduce cost just for users, and sort of give the users and the protocol, a chance to survive without paying these massively high gas fees. So this is the way that we see the new purpose for layer 1 and the new purpose for the ecosystem itself. And of course, layer 1 makes possible all of this. I mean, without it, you just can't even do a rollup. You can't even do state channels. So it's really important that Ethereum exists in its current fashion. But of course, layer 2 is going to bring to us a whole new realm of possibility for computing and for protocols in general. So just to give a bit of an overview of the Fuel timeline right now. So we're fighting as hard as we can to get our version 1 to mainnet. So that's going to include the features you saw above. Our version 1.5, we're trying to get spec'd and released to testnet by the end of the year. And that's our 4300 TPS version. So what's nice about our throughput is not only that you're getting, fancy pants, big numbers, but also that we can produce 4300 TPS blocks and situations on a $20 DigitalOcean node. So this is very critical for the price cost average versus other chains or rollups that need high cost ASIC provers. So one huge benefit of using an optimistic rollup is you can produce these massive transaction per second throughputs, but without the cost. And we're fine with taking the the fraud-proof approach. As Vitalik will tell you, as anyone will tell you, it's as safe or even more safe than snark-related tech. And really, to be honest, it's a lot simpler. And the trade-offs, especially with hash time lock contracts, are minimal. The 1 week withdrawal period is only really an issue if you can't support hash time lock contracts. fortunately, most rollups right now can, including Optimism, Arbitrum, and our own. So with a hash time lock contract, it means an exit from a 1 week can go down to 5 to 10 minutes, if depending on how much risk you want to take. So hash time lock contracts are a fantastic way to solve a lot of different problems, and they're really simple and they're easy to implement. So that's just a touch on that. So the next thing as well that I want to touch upon is our Fuel 2.0. So Fuel 2.0 will add in the UTXO-based Ethereum style smart contracts. So the main difference here is just the performant benefit of it. Because we're building upward from parallelism and we don't have things like global state, we don't have the state bottlenecks that Ethereum has and that the EVM has. The whole reason why Ethereum can't scale right now is because of state bottleneck due to the way state is done and due to the way the EVM works. So recreating that and putting that inside your chain or rollup, it will not address these issues. It will eventually come up, whether it be this year or next year, and you'll have to, again, address that. You'll have to, again, try to challenge that. So because we chose a UTXO model, we don't have this issue. The UTXO model effectively turns state into state access lists and allows us to break free of that bottleneck, which means that we're really at a point where block production and block verification can be done on trivial democratized computing hardware, and we can do it at massive scale. So massive throughput. And really the only bottleneck there would just be something like bandwidth or things like that, which are very addressable. So as well, one thing I wanted to do in this talk was just make a bit of a stand here and make sure that on every recording that I do and every presentation I do, that we start taking back the term optimistic Ethereum. I've been working on Ethereum for 6.5 years, and I'll be damned if a single project would like to take this term as their own, because I think optimistic Ethereum should be left for all optimistic rollups. So anyone using this term,
100%,
and not just a single rollup. It's a great term. We're using it all the time, and I wouldn't want this to be directly associated with that. I can talk about the OVM as well, but we'll leave it at, I'll leave my stand in the hill I'm going to die on, as optimistic Ethereum should be left for everyone and not just a few projects or one project. So there's our links in Twitter. We are going to ramp up Twitter activity to just disseminate all of the different features and different things that we've done to make Fuel worthwhile and to really show its potential. And of course, as we go to mainnet, you'll be hearing a lot more about that. And yeah, once again, our main focus right now is not smart contracts. Our main focus is to double down on transfers and swaps. We still think that's extremely valuable and that needs to be done, and that work needs to be done. But of course, we're not just going to stop at transfers and swaps. We are going to bring to you a fantastic virtual machine experience. Depending on our resource situation, we could have copy, paste, drop and go Solidity contracts, but I think we might have something even better than that. So we'll see how that goes. So that's the end of my presentation. So I guess we'll just go into questions.
Yeah, no, thank you very much. Really appreciate it. If you can tell me a little bit more about your team, like who else is in your team, some team members, like are you guys, did you guys raise the funds, or are you fundraising, or what's your plans?
Yeah, so we're to touch on the team. So right now, we have members like John Adler, who's sort of the creator of optimistic rollups, if I'm to be so bold, and created the minimal viable consensus paper, which is effectively what we now call the optimistic rollup. So John is co-founder and does a lot of our research and obviously technical design and things like that. So John's one of our seminal members, and then as well we have members like Shahan, who was a co-founder of Pegasus, the 2.0 client for Ethereum. So his specialty and what his PhD in is in parallel computing. So once again, a fantastic fit for, our kinds of architecture. And then we also have Dave Mihal, which is a lead at the Burner team. So I don't know if you've used Burner wallets before and all that sort of stuff. But, we're kind of active a little bit in the Burner community there. And, is where I think we're going to have a lot of fun with just using real throughput with real security. Dave's another member of our team. And then Sam Bourne, who is, basically started out doing a project called Kolu, which was one of the first color coin projects. It was really early on in the space, so even before Ethereum, and was a product lead at Wings. And so, that's just a background on some of our full-time team. And then in terms of financing and funding, I mean, we're still actively in a raise right now, so that's, ongoing. I think, the reception has been fantastic, and I think because our focus is more singularly on targeting our transfer and swap use cases, we really differentiate that way, and then as well, we differentiate because we're really targeting the parallelism, which is harder and does change a lot of the dynamics of how you build things, but the end result should be that we have many different options for fantastic, massive global throughput. Which is really what we want to see from rollups. We want Ethereum to be a global, settlement system. We don't want it to just be a bunch of us nerds doing a bunch of DeFi things. We want it to be everyone and the whole globe. So when you talk about the whole globe, you really need to think about, where can you find every single opportunity to make it more efficient? Thinking about parallelism is definitely an area there. Yeah.
Gotcha. No, thanks for the whole introduction and talk about what Fuel Labs is basically doing. I wrote down 8 use cases that you guys are working on that encompasses everything is doing. I have a few questions, but before I ask, because my questions never end, and does anyone have any questions?
I have a question. So Nick, very nice presentation. Thank you very much for that. So when you talk about the block states bottleneck, and I absolutely agree with that. Do you have because I haven't done that. Have you done a research into like what's the ceiling of a one single node EVM be able to deal with when it's going to hit the bottleneck? Do you know?
Yeah. So and once again, this is something where I think John would really shine in terms of giving you like a complete, thorough answer of why this is. It really does stem from a random access memory issue, and the fact that when you're validating transactions, it needs to be done sequentially. So if you have 500 TPS, that means for systems that are an EVM-like model, you need to go through each one after the other, because you don't know where state is being accessed. So this can be sometimes optimized a little bit with some analytical work at the beginning, but in general, if you're choosing this model, you're going to be serializing things. You're going to be doing state work serially, which is just awful. So if we're doing the globes transactions and we're trying to do that serially, it doesn't matter how big of a computer you've got, like you're going to hit bottlenecks. So with the Geth clients, I think I've heard numbers around if we were to just let block size go for a minute and just sort of go nuts, it could probably get around 500 TPS with the current model, which is really nothing to sneeze at. That's a huge amount of throughput, really. But the thing is, we don't know that for sure, because running complex transactions with a lot of different hoops and a lot of different calls through that system, it's never really been done in terms of max throughput. So you might get like 500 TPS for basic transactions or simple low execution opcode calls. But if you're talking about lots and lots of complex calls or many different kinds of calls, you can imagine that's probably going to reduce by orders of magnitude. So it's really hard to say, but yeah, it really does bottleneck around an area that is tough. Now, mind you, it's not all about the bigger number. Like TPS is one aspect of it, but TPS also reflects cost. So if you're talking about throughput, you're not just talking about like jamming as many transactions as we can per second. It's like, okay, cool, 500, that's great. But the thing is you get into the order of magnitude higher numbers, what you're talking about is not just a higher number of throughput, you're talking about a lower cost, which is actually what you want to nail as well. And you don't want to have your verifier, especially in the optimistic rollup, to only be run on these massive supercomputers. Like you want it to be that anyone can open up a laptop, or even in Fuel's case, open up a phone and be able to validate the entire chain. That's really the major difference there. Yeah.
Sounds cool. Thank you very much.
Awesome.
That's perfect. Any other questions? Okay, I'll go for one at least. So you mentioned 7 to 8 use cases, and the way it's basically how the technology can be used, and those 8 use cases are what Fuel Labs can support in the near future with by the end of this year or probably in Q1 2021. Are you guys trying to be the platform where other developers can build application using your technology, or are you planning to create a product out of your one use case and then rolling out a solution for the consumers themselves?
So we're kind of doing a little bit of both, but I'd say we're targeting developers who don't necessarily need smart contracts. They don't need that kind of work. What they need is throughput, payments, and scale. And so that's really the developers that we're looking at right now. We're really trying to cater to that group. And once again, because of the properties of what we offer between transfers and swaps and a bunch of other things like that, at this really reduced cost, it's kind of perfect for those groups. So that's really what we're looking at right now, is the people who need transfer and exchange tech. That's our target right now. And we definitely beat out all the other optimistic rollups in terms of simplicity, throughput, etc. For those cases, and we'll continue to do that with our future versions as well. So really, that's our first sort of stand, but we're not stopping there. I mean, smart contracts in the UTXO model is sort of our next feat. So we're gearing up for that right now in terms of hiring and everything else to be able to sort of deliver that, at least a test net or a full specification and more within mid next year. But with that, I mean, you'll be seeing a significant number of improvements to how things will work, and particularly to, I think, the possibilities for throughput parallelization, which will be, greatly increased over current designs. Yeah.
Gotcha. Okay. And many conversations that I'm hearing from different experts, they are divided in between whether to think rollups in general or layer 2 in general as a band-aid solution versus permanent solution. Which particular, I can see Yuan already laughing at this. Which camp are you guys in? Like, do you guys think that no matter how much speed and scalability with Ethereum 2.0 can achieve with sharding, we will definitely need ORU and all the layer 2 solutions? Or do you think with proper ETH 2.0 with proper sharding solution, all the layer 2 solutions will be obsolete? Which camp do you guys believe in?
Well, I would say this. I mean, all indications right now are that with the 2.0 design, Vitalik's plan to scale Ethereum 2.0 is optimistic rollups. I mean, the shards themselves actually can't get a lot of throughput. Yeah. They're actually quite limited. And so we're actually like hoping and praying 2.0 comes out faster, because then we can run our rollup in specific shards and actually, maximize our throughput potential. So really,
multiply, you're right.
Yeah, so 2.0 is actually like essential for us to see more throughput. But the main reason why we like 2.0 is that it has just more security. I mean, the whole idea behind trying to go for proof of stake is really to increase that base layer security. I mean, if we're actually clearing, we can imagine a world where Fuel's actually clearing 4,300 TPS in a magical world. Like, I'm not saying that's even going to happen, but let's say we were, that's a heck of a lot of value. And with, I don't know how many mining groups we have mining Ethereum, that's not actually a lot of security. You would want a more secure model to be able to really secure that chain. And I'd also highly recommend taking a look at John's other project that he's currently working on, which is Lazy Ledger. And Lazy Ledger is effectively what 2.0 is kind of becoming, which is a data availability layer for optimistic rollups specifically, imagining the shards as the data availability area, and then imagining the rollups is where it's going. So I'd highly recommend as a layer one to take a look at that as well, because it's going to be sort of a roll-up paradise. You could imagine it that way. But of course, will they be able to compete with Ethereum's network effect? Who knows? The question remains. As any other layer one competitor, it is yet to be seen. So we'll figure that out, I guess. Yeah,
no, that's a great way to look at it. I was not looking at it. I was like either or mentality, but that's a great way to look at it as well. Why not just like optimize one of the shards or use one of the shards for your own use case, and that you instantly get the multiplying effect right away, rather than competing with these two. So yeah, okay. So it's not a band-aid solution. It's more like a it's a long-term solution on top of ETH 2.0.
Yeah, absolutely. And I'll also say too that with every solution, especially in engineering, it is always just a battle of compromise. So you're always finding the different compromises.
Yep.
And currently many of the optimistic rollups use a sequencer model. So there's a sequencer.
Yep.
It doesn't mean they can censor, you build in censorship resistance, but you have some party generally sequencing. And trust me, if there was another way that was actually better and secure and actually theorized, we would use it, but there is not. And so a single sequencer is still the best. It still has the best trust guarantees. So that's what we're doing. But look, I mean, if someone can come up with something better, tell us. We would love to implement it. Yeah,
that's perfect. Like for the people who may not know about what sequencer is, explain it in like a couple of sentences if you can. If you need to go in detail, feel free to do that. So.
Yeah, I mean, right now a single sequencer just means you have one party organizing the mempool and producing the blocks. So then taking fees. And this could be broken up potentially into a group of sequencers as well that take turns doing this and take turns doing fees. But a sequencer in this case is just a block producer. But the benefit that we get with optimistic rollups is that you can always put in things in the contract, like in Fuel, that just allow you to post your own blocks. So anyone can post a block, anyone can post a transaction. They just have to go through layer one. So they don't get the benefit of the speed or anything like that, but they get the benefit of censorship resistance. So the block producer can't censor you, which is very, very important, as we see in the world of social media right now, but will definitely bleed over into the financial world for sure. So yeah.
Okay, no, that totally makes sense. So just adding a little bit of explanation that I've learned from previous understanding. Sequencer is very similar to Relayer, where instead of you directly, for the purpose of fees and everything, instead of you directly submitting to the blockchain, you would pass your transactions to a sequencer / Relayer who would give you the proof of the transaction, and the sequencer / Relayer would put those transactions on blockchain on your behalf. But I didn't know that I can bypass them in this design. So this is something new to me. So that's perfect. Thank you.
Yep. Yeah, that's basically it. Yep.
Okay. Any other questions, guys? Okay.
Awesome.
Looks like we are done. Hey, thank you very much, Nick. Really appreciate it. This is Fuel Labs has created many, like much strong technical solution. I hope we can, you guys can close your round. I hope you guys can create a very strong solution around developers. And instead of doing developers doing everything from scratch, this is a great place to start. So good luck with that. And if anyone else can help you do that, please reach out. But other than that, thank you.
Awesome. Absolutely.
Thank you.
Yeah, thanks, guys.
Thank you, Nick.
Thank you.
All right.
Kevin, off to you. You want to conclude?
Actually, I think before we conclude, Stephen, can you introduce a little bit of your background?
Sorry, hey.
Hi.
Hey.
Yeah.
So I actually run the Caribbean Blockchain Alliance. We're mainly an advocacy group. We focus on blockchain education, blockchain agnostic typically, but also public policy for dealing with regulators, dealing with government agencies and whatnot within the Caribbean region. So in terms of this, I came onto this pretty much just keeping on track of everything going on in the space. in terms of updates to protocols, especially because when we kind of develop our curricula, which we're trying to start now, you know, we have to know what's going on. We have to know the updates and the changes and whatnot. So,
Stephen, can I actually get your contact?
Yes.
Yeah, you're in a region which I'm very interested in. So yeah.
Oh, awesome. It's interesting because it's very scattered, right? So what we've done over the last 2 years is kind of try to build a community to kind of keep everyone together, keep track of what's going on in the different islands and different countries. So right now we're just starting this year to really push forward in terms of our agenda, like in terms of the education stuff, in terms of putting together the public policy stuff. So it's all very new and it's kind of open ground too, which is pretty cool.
Yeah,
awesome.
Stephen, you know, Ilana is our co-founder. I guess Crypto Chicks, they did some hackathon last year, right?
Yeah, we helped out with that actually.
Okay, that's nice.
So, and that was great. And 2 years ago, we actually worked with BlockX to do a very small pilot course in the Bahamas.
Okay.
So that was pretty cool too.
An email. Awesome.
Okay.
Wonderful.
Thank you everyone for your time.
All right.
It's wonderful.
Awesome.
You know,